let's take a look at the square function, y equals x squared. I like to nickname this one the u because we'll see that's really what it looks like as we graph it. All right, let's jump in. We'll make a table of values just to be sure we know our exact points really well. Once you practice this a couple of times, you should really know this one's basic shape and how to sketch it really quickly. So we'll start with our typical -1, 0, and 1 for x's. And when you substitute that into the function, you see you're just squaring each number. So remember, if you square -1 or if you square any negative number, you should have parentheses around those. Be careful if you ever enter something like this into your calculator. Your squared negative number should become positive. So -1 squared should be 1. All right, 0 squared is 0, and 1 squared is 1. Okay, if you wanted to check out a couple of other numbers, you could plug in, say, -2 squared is 4. Same thing with 2 squared, 4, if you want a couple of extra points. So let's go ahead and graph those. So we have -2, 4. We have -1, 1. We have 0, 0, 1, 1, and 2, 4. All right, so you should see you have a nice U-shaped graph. All right, more or less. Okay, so this is the U. Now let's dive into some of the characteristics. First, we'll look at domain and range. And remember, domain is just the list of all the x's. Range is the list of all the y values of your graph. And we'll use interval notation. So let's do domain first. Remember, domain, you read from left to right. So you're seeing what possible x's are on your graph. And so we have our arrows here. And you can see that the graph slowly moves more negative, but all negative x's, every real number, all positive x's, it keeps on going. So our domain here is just all real numbers. And you can really look at those arrows to see, okay, we go forever to the left and forever to the right. That's how you should kind of get experience with seeing the different ways, the different functions that are all real numbers for domain. So let's go ahead and notate that. -infinity to infinity. All right, so the range is all the possible y values. And so look from bottom to top. You can see there are no y values until you get to 0. So we want to include 0. We'll use brackets. And then both arrows on either end of our graph are extending up. And so all possible y values as we continue to increase from 0. So let's notate that. We'll say bracket 0 to infinity. That's the list of all our y's that are possible for the square function. All right, you can see, like with a lot of our other essential functions, our intercepts are not too exciting right now. We haven't moved these graphs around. They're just our starting points, or I like to call them our parent graphs. So the origin is both our x and our y-intercept. Okay, symmetry. The square function is similar to the absolute value function that you may have just looked at. Remember that we look for y-axis or origin symmetry. And in this case, you can see we have y-axis symmetry. Okay, and that's determined by seeing that the graph is a reflection across that y-axis. So for every xy on the graph, there should be a point -x, positive y, that same y value. So you can see integer examples of that. 1, 1, and -1, 1 are both on the graph. 2, 4, and -2, 4. So you see they mirror across that y-axis. Okay, and sometimes you'll hear a function with y-axis symmetry is called even, an even function. So we can write that down as well. So even. And if it was origin, so symmetric about the origin, which means it would just be rotated 180 degrees and land on top of itself. Functions that have origin symmetry we can call odd. So those go together. All right, finally, let's look at increasing and decreasing intervals. And you'll see this one is also a lot like the absolute value function. So let's start from the left and we'll see what our graph is doing. Okay, so you see the arrow means we're coming from negative infinity. Remember, we're looking from left to right, and we want to use our x's. So we'll be writing x values to talk about what the y's are doing. So from negative infinity, we're decreasing until we get to 0. Okay, so we'll have a decreasing interval from negative infinity to 0. And then you can see, keep following the graph with your pencil. Once we pass 0, our y values start to increase as our x's do. So that'll be an increasing interval. All right, so we're decreasing from negative infinity to 0. And remember, parentheses around all of the endpoints here, because that point of change, you're really neither increasing nor decreasing. And so that's the standard notation that we use. All right, and then from 0 to infinity, we are increasing. Okay, and so again, use those x's to talk about what the y's are doing. All right, this was a quick look at the square function, y equals x squared, and some of its characteristics. So when you think square function, or when you hear the equation y equals x squared, think of the u graph.